third question, in the diagram we have these two lines. One is the curve and one is the straight line, right? So here you can see that it intersects at point A. So now for part A, we need to find the coordinates of that point, right? So since these two lines intersect at this point, so what we can do is to find the value of the x coordinate and the y coordinate, we can use the substitution method. Using this equation, sub into here, find the value of x and y. Then we just rearrange, and you find out that it is a quadratic equation. Okay, then we need to find those two values, right? Our two answers. So this one we use the factorization method, and using calculator, then you find out these are the two answers. Then later on, your final answers would be -4 and 5/2. So we need to reject one of it, so we can determine based on our diagram. So you can see that this point is actually above the x-axis, means the y values must be positive. Okay, this means y equals to -4, we need to reject, right? So we have found our y coordinate. Now we just substitute this number into here to find the x coordinate lah. Okay, so x coordinate is -1/4. So for point A, the coordinates are -1/4, 5/2. And the next question is we need to find the area of shaded region Q, which is this pink color region here, right? So to find area, we have two steps. So the first step is choose our axis. Okay, so here you can see that this curve is actually not a smiley face or a sad face, so it's a clue that we can use the y-axis. Okay, there's another clue here. You can see that this region, right, it is bounded by the y-axis. Okay, so this is also a clue that we should use y-axis. And the second step is to identify our shapes. So if you see this region Q, it is bounded by another two lines, right? The straight line here and the curve. So what we can do is we split this region based on the bounded line. Okay, reason is because now you can see there are two shapes. So this one, if we look from the right side like this, you can see that this region is actually area under the curve, right? Area under the curve. And this part is actually a triangle. So to find our area, we just need to add these two shapes, then we can find our area already. So this one, we need to use the integration formula because it's area under the curve. This one, we just need to use the area of triangle, which is the 1/2 times base times height, right? So for this one, let's use the integration formula. So since we are using the y-axis, so outside should be y, inside should be x. Alright, and then we need to integrate based on the values here. So we need to find the starting point and ending point. So starting point here should be this one, this point, which is the y-intercept of this curve, which we have not found yet. Right? So we need to find the y-intercept first. So this one, we just need to substitute x with 0, then we move the square to the other side. So please remember, when you move the square, there will be two answers, positive and negative, and here we need to split, right? So since this point is actually above the x-axis, so means y is positive lah. So this one we reject. So our value would be √6. And our highest point here is 5/2 lah, from the answer in part A, right? And here, the things inside the integral, we need to change it to become y. So what we can do is use back the equation, rearrange the equation a bit, right? So x on the left, everything on the right. So this x will change to 6 minus y squared. And then for area of triangle, so it's 1/2 times base. So base is this part, okay, and we know that here the length, the coordinate here is -1/4, so the length is 1/4 lah, right? And this part is the length of the height, so here it's 5/2, but this part we don't know, right? This part we don't know. This one is actually the y-intercept of this line. Okay, so let's rearrange this equation a bit, find the y-intercept. Okay, so it's a/3, right? So to find the length, it's just 8/3 minus 5/2. So this is the working to find the area. Right, so there's one mistake here. So I'll let you all to have 5 seconds, see y'all can detect detect the error or not. So the error is this part, this region, if you look at the diagram, is actually left side of the y-axis, which means this value is negative. Okay, so what we need to do is just to add the modulus. So please remember to add the modulus. Right? So please remember the areas which are on the left side of y-axis, like for example this part is negative, right side is positive. Okay, so now let's integrate this part. So 6 here, I need to add a y. This y square be power plus 1, then I need to divide the new power, which is 3. Okay, then I put these two values here. Then this one we can just simplify already lah, which is 1/48. Then later on, I need to substitute these two values and minus those two values together. Right, so here's the working when we substitute 5/2 inside here. Then we need to minus the value we substitute square root 6, right? So this is the working. Then don't forget to plus the 1/48 here. Then we simplify, right? Then later on, this is the final value. So you can see, right, this value, if without the modulus, is actually a negative value. Okay, so please remember to put the modulus when the area is on the left side of the the y-axis. Okay, so our final value would be 0.0272 unit square. And the last question, we need to find the generated volume for shaded region P, which is this blue color region here, in terms of pi, which means for pi we don't change it to 3.142, okay, remain as it is. And here we need to rotate one circle around the x-axis, right? So same as area, we have two steps. The first step is to choose axis, which technically is already mentioned in the question lah. So yeah, we need to use the x-axis. Okay, step 2, identify the shapes. But here for generated volume, let's take a step back. Let's find area first. Okay, imagine we are finding the area. So this part is actually bounded by the curve. Okay, and then since we are using the x-axis, so it's bounded by the x-axis here. So this part is actually area under the curve, right? Area under the curve. So area under the curve, we use the integration formula, right? So since for area, we're using integration formula, this means for volume, we also use the integration formula, right? So for the integration formula for volume, let's add a pi, and then the integral. So the outside, since we are using the x-axis, outside should be x, inside should be y, and don't forget the square. Right, so the starting point and ending points we need to look at here. Okay, so starting point here is the x-coordinate of a, which is -1/4. Then here the ending point is 0, right? So the integral inside, we need to change it all to be x, right? Because here we need to integrate in terms of x. So for this y square, we just substitute 6 minus x, the curve's equation. Right? Then we need to integrate already lah. So 6 here we just add an x. X here we need to add 1 to the power, divide with the new power, which is 2, right? So and then the 0, -1/4, we put it here. Then we substitute inside this bracket, right? So substitute 0 inside, everything will become 0. Then we need to minus the value which we sub -1/4 lah, right? So please write out this working. Then later on we simplify, and this would be our answer, 49/32 pi units cubed.